So this is applications of our trigonometric equation. So what they're going to do is form a triangle, and we're going to solve for that given value. So it says here an astronaut is in a launched rocket currently 15 miles in altitude. So we just think of it this way. So right here, they're at 15 miles. That's our distance here. So this is our distance. And it says a man standing 2 miles from the launch pad. So here's our launch pad. And then we have this little person sitting over here. And he is 2 miles from here. And now obviously this is not to scale. It's just to give us a representation. So you can already see that's our triangle right there, because that's our 90. And so the question's asking, at what angle is she looking down at him from the horizontal? So we're assuming this is the astronaut. She's up here, right, in her rocket. And we have some horizontal, and she's looking down from him. So that's our theta that we're looking for. And if you remember, alternate interior angles are the same. So if that's theta, then also if this angle is theta, then that angle is also theta. So now that's our trig ratio. So for this theta, what do we have? We have opposite over adjacent. So that is tangent. So tangent theta is equal to 15 over 2. So then solving for theta, we would get inverse tangent of 15 over 2. So plugging that into our calculator, inverse tangent of 15 divided by 2. And we get, make sure your mode is in degrees here. We get 82.4 degrees. So we get theta equals 82.4 degrees. So that's our angle here, 82.4, because that is 82.4 degrees. Okay, so let's look at this one. This is a really good problem to work with. So what we're doing here is we're actually going to find the area of a triangle based on a given theta. So what we have here is two side lengths, one that's 4 and one that's 5, and then we have some height. And the area of a triangle is 1/2 base times height. So if you look at it, we already know that our base here is 5. That's what this is. This is our base right here. And so all we need to do now is find out what the height is. But once we introduce that variable, you notice we have an h and a theta, and we've got multiple variables, we need an extra equation. And so we need to use that angle theta. And so we have to draw the triangle that we use the angle theta with, and h. So it's this one. And then we just transfer everything down. So that's the triangle we're dealing with here. And so what is the relationship between h, 4, and theta? Well, that is an opposite over hypotenuse. So we end up with sine theta is equal to h over 4. So that means h is equal to 4 sine theta. And then that allows us to come back up here and say 1/2 times 5, 4 sine theta. And then simplifying this, we end up with 10 sine theta, because that would be 20 divided by 2 is 10. And so now what we have done is we have written the formula for the area of a triangle as a function of theta. So we have two sides, 5 and 4, and an included angle theta, and we use that to create a formula for it. Okay, so then we get some questions about this. So the main idea whenever you have triangles is, what is the largest area? So let's take a look at it. We have our sine function here. And remember, when this graphs, it's going to go up 10 and then down to -10. We use the amplitude. So let's look at Desmos and let's see how this works. So we have our triangle and we have our sine wave. And the sine wave looks weird because I've had to put this to scale, but you can kind of see it right there. And obviously this triangle is not to scale. It's just to make it work. So as you move the angle through, you can see, going through all the angles, that we are increasing here. There's 67 degrees. It goes up to our maximum right there. So right there is 0. If our angle is 0, we don't have a triangle. And then once we have an angle, you can see our angle moving here. We can actually grab it here and move it. And as we move to the highest point on the sine graph, this is our area. This red line is the area function. So we get to here at 90 degrees. 90 degrees is our highest point. And we already knew that that was our pi over 2, or 90 degrees is the highest it goes. Because when you have a sine function, it goes up to 90 and then down to 180 at 180 and then down to the lowest part, which is negative, and then right back up. So this is just going to continue that sine curve. So we already knew that the highest point for a sine wave occurs here. And what is that point? It's the 10. It's our amplitude. So when does that occur? It's at a 90 degree. 90 degree angles is the highest that it will get. Pi over 2 is where it is. Anything less than that, and you think, oh, what if it goes farther? If it goes farther, look at it. It's now going down. So our largest triangle that we can get will have an area of 10. And we already knew that because, again, our largest area, the largest value we get here is 10, because the largest sine we'll ever get to is 1. So if the biggest this gets to is 1, then the largest sine value would be 1. You can easily just replace your sine value with 1, and it says it's 10. That is our biggest right here. So the largest area is 10 square meters. So now it's saying find an angle, theta, needed to have an area of 6 meters squared. And that's where our equations come in now. So we take our area, which is 10 sine theta, and we say that our area is 6 meters squared. And then we solve for sine. So you just divide by 10. So we get 6/10. I know that's 3/5. We can leave it. And then we do our inverse. So theta is equal to sine inverse of 6/10. We'll plug that in our calculator. So inverse sine of 6/10, or 3/5. And we end up with 36.869. So this equals 36.869, so we'll make it 36.87 degrees. And why don't we take and look at that? So it's supposed to be 6, right? We're supposed to get an area of 6 when we have a 36.87 degrees. So if we look at the calculator, you can see there's my area. I've already got the calculation. If we move it to 36, so if we put in there 36.87, there it is. See, 6. So that's what's happening here. This is a height of 6. If we zoom in there, our height right here of our sine function is 6. That's what's happening. As we move along, the height of our sine is the y value, which is the area, as we go through. So there you have it.